we were looking for the problems we were looking at. We were looking to see, we want it to have these characteristics. It has to be a cubic function. And we only have the functions up here. So if we want the y-intercept to be at -1, that means that we need to have all the different y values to multiply to -1. And so remember, this first row was all the ones that had a multiplicity of 1, or had 1, 0, and the second row is the ones that have 2 roots. And so our y-intercept needs to be we need to multiply it together and get -1. And so if we have this -1 times 1, that would work. Or 1 times -1 times 1. That would work. So you have a choice of which ones you want to use. You could use GHJ or P of X and H of X. And for me, I chose these 3. And so that means this one has an x-intercept at -1, 1, and what is this x-intercept at? 1. So that means I'm touching and going back here, and I cross here. It goes through and it touches here. That is one of the graphs you could have drawn. So for our similarities and differences, we know that we all had a y-intercept at y equals -1. What other similarities did you have to mine? And y'all sketched y'all's. We should have all had the same number of zeros, because you couldn't have a 0 x at 0, so that means these guys were automatically thrown out. So we should have all had 2 zeros. What about your tails? Do they all go the same direction? Did you have everybody have it to where one's up and one's down? Did everybody go the same direction as me? Or did some of y'all go maybe this direction? So some of you may have had opposite on that one. Some of you may have had a different one where we touched and went back. So those are some things that could have been different than mine. On this next one, we have a 0 at x equals 1. And we want it to be a multiplicity of 3. So which of these graphs has a 0 at x equals 1? Oh, crud, undo. H of X does. Where else? We need to have 3, whether it's 1 or 3 from here or 1 from there and 2 from, or and these have a 2. So we can do 1 and 1 or 3 from here. I did H of X and R of X. You could have also done J of X and R of X. So if you did, oops, that one. These two, your graph will look something like this. If you instead did these two, what would have been different is your graph would have gone the opposite direction. Oops. It would have gone. So what are some similarities and differences that we had? What are some similarities and differences between these two graphs? They both have the same 0. What else?
They end differently. They go different ways.
They're different because they go the opposite direction. What am I spelling? Cannot spell directions today. What else is different? Is there anything else? No? Pretty much this is the only difference is opposite direction, and then we have the same 0. What about if I wanted 3 distinct real zeros? So out of my graph up here, if we look, out of your choices, what are really the only 3 zeros we have?
The last one.
We have -1 and 1. What's another one we could have done? We need one more 0. F of X. So this is one way you could have gone about it. And if you did this way, your graph would have looked something along this lines. Another option you could have done would be this one. So what's different between those two?
I think it's just the same thing. They have the same zeros and it's a different direction.
Yeah, so it's the same as what we just said. So which quadrants are 1 and 3?
Is it this top box?
So this is quadrant 1.
Oh, it starts from
Yes, it goes, it's weird.
the, so then this bottom.
And so it goes this way to go around. So here's quadrant 3. It is, it goes back to polar notation is where it goes to. And so it's all about physics on that part.
Well, that's something from here.
Well, I got it, it's too hard, too much math.
And so those are quadrants 1 and 3, or physics and trig, excuse me. And so
Could we do a graph like the one we did above? 'Cause
this
if
one,
we- Yeah, if we flip it, because of being those two quadrants.
well, but it also has this quadrant and this quadrant involved.
What about C?
Very similar to C. What could we do with C to get it to where it's only, because this one touches here.
Put it at 0.
Put it at 0. So that would make it these two, because we wouldn't have a multiplicity of 3 at 0. And really, there's only, out of these options, there's only one way to graph it, was those.
How do you write 4 in Roman?
What?
How do you write 4 in Roman?
It's
That's what I
1.
thought, but
D1 or
No,
1D?
it's V1, and then 1B is 6, I think.
It's 1 and then V. If it's before, it lowers it. If it's after, it adds. So that's 4.
Quit?
No, because I'm just saying, never mind.
So we want to have 3 imaginary zeros. So imaginary means it doesn't cross the x-axis. So here is 2 imaginary zeros. I need to add 1 more. So which of these 3 graphs does not cross the x-axis?
The second one.
Oh, it touches it here.
Oh, crap. The one you circled.
The one I circled gives us 2. I need 1 more. And so the ones that give us 1 are this first row in blue.
F of X.
Well, it touches the x-axis here.
But none of them.
Then none of them. So it's impossible. So, what are the possible combination of real and imaginary zeros for a cubic function to have? So what is a possible, so let's think about it. So if you have a cubic, that means there needs to be a total of 3 zeros. So you could have 3 reals, right? I don't know why I wrote it that way. Because we were talking about Roman numerals earlier. And 0 imaginary.
2.
2 real. Can I have 1 imaginary?
Could it be on like the Y?
Mm-mm.
1 real.
1 real. 2 imaginary.
Can you have them all imaginary?
Because then we can't, because we looked at it and we couldn't see any way that we could have that 1 go through. So all imaginary sets need to have a set of 2. So like you could have 2, you could have 4, you could have 6, but if we're dealing with cubic, that means these guys are out, right? 0, 2, 6. A cubic function must have 3 zeros. From the fundamental theorem of algebra. However, the number of real and imaginary zeros can vary. A function may have 0, 1, 2, or 3 imaginary zeros. What is her error? It can have 0. Oops, did I go too fast?
Yes.
Is that add or odd?
Odd.
Okay.
Augie, Catherine, and Chili each wrote a cubic function with the zeros at x equals 3, x equals 1, and x equals -4. Augie's was f of x equals x minus 3, x minus 1, x plus 4. It has the 3 zeros, and you can check it by setting those equal to 0, and it's solved. Catherine had the same thing, except for she put a 5 in front of it all. And Chili had 2x minus 6 times 3x minus 3 times x plus 4. And it has those 3 zeros. And so we're going to look and see they're all 3 right. Why does multiplying by that constant, how does multiplying by that constant affect the graph? So I want you to go ahead and graph those 3 and see if you can answer question 8. You may want to adjust your window. You know we need to be between -4 and +3. And so I'm going to go ahead and change my x-axis from -5 to +5. Just kind of give it zoomed in there. And for my y-axis, I went from -50 to +50, just to give me some room for the way that things look on the graph. So here is Augie's graph. Would I do the same thing, but with a 5 in front of it? What did y'all see it happen to the graph?
It just changed the shape.
Change the shape. How did it change the shape?
Like it went up higher and got skinnier when it went down.
So it stretched it up and down, right? So we had a vertical, we basically pulled it apart vertically, right? That's what that constant did. So let's see if that holds true for when we do Chili's. So we didn't have a constant in Chili's, right? How come did it stretch it more?
Because the 2 and the 3 were on the inside of the parentheses.
Oh, okay. So we had it, we just had it in a different way. So this is the same thing as me saying 2x minus 3 times 3x minus 1 times x plus 4. And so if I was to combine the coefficients, that'd be 6, x minus 3, x minus 1, x plus 4. So that 6 was bigger than the 5, so it stretched it more. Okay? So we said that it gave us a vertical stretch. So why do you think the zeros remain the same after that multiplying by constant?
It's not doing anything to the zeros, it's just stretching it.
It's just stretching. How many different cubic functions can you write if you're given a set of zeros? Infinite. Because there's an infinite number of coefficients you could use. What do you think would happen if my coefficient was, instead of being 5, being 1/5?
Vertically compressed.
Okay. Let's see. It was 5, that's what I said. Did it vertically compress it? Okay. So I want y'all to think of 2 different cubic functions with these different characteristics. So if we know the zeros, let's go ahead and find the factor. What factor would x equals 2 have? What factor would x equals 0 have?
Equals 0.
So this is going to create the x minus 2. This is going to create the x. What would x minus 4 create?
Equals 4.
So those are the 3 factors we have to work with. And I want you to come up with 2 different cubic functions. So the equation I came up with, one of the equations, so what do you think that negative is going to do? Flip it. It's going to go the opposite direction. That 3 is going to stretch it out. Another one I came up with was just the basic one. And for lack of a better name, it's like the parent function of the set. You could have come up with different ones. I want y'all to go through, oh, actually, I need to go through this one with you. So if x equals 0, that's just going to give you that factor of x. X equals 2i gives us a factor of x minus 2i. X equals negative 2i gives us a factor of x plus 2i. This is not something that we're familiar with working with, so we need to multiply that out. X minus 2i, x plus 2i, so it gives you I squared, negative 2i x, positive 2i x, and negative 2 times negative 2 gives me a negative 4i squared. What does I squared become?
0.
Not 0,
Well, it doesn't
Negative
because
1.
it just-
negative 1. Are you talking about these 2?
Oh, yeah.
Okay, those 2 do cancel out. The I squared becomes negative 1. So 4 times negative 1 means that section is now a positive 4. So this factor here is x squared plus 4 when combined. And so my basic function of this is x times x squared plus 4. Now I'll come with one other one. Anybody give me their other function?
Two x, and then parentheses 2x squared plus 8.
That's another one. So now go through the other ones and find. So when it says a multiplicity of 2, that means the exponent's 2. So you go through and you find the factors the same way. You just put an exponent of 2 on the one that's a multiplicity of 2. So what's another function you could have written? Anybody give me another one? What about 2 in front of it? No, not plus. So that's another function. Any other coefficient would work, or if you multiplied a 2 through one of these two parentheses. Or something else through one of those parentheses. Or put a negative in front.
Why would you still have the square if you're already multiplying the two?
The 2 is not a squaring, it's not the same thing. I could have put this number as any number. It's just a coefficient. So whatever coefficient number you want to write there.
So it's like just making it different from the first one?
Yes. So for this next one, we had to think a little bit further. Because it says it wants to have a y-intercept at y equals negative 24. So we need to find all 3 y-intercepts of what we have, multiply them together, plus whatever we want to have as a coefficient, or as well as what we have as a coefficient, and solve. And so that tells us our basic one. This is going to become that coefficient. Now, anybody come up with a second one? As long as you put 2 negatives involved with it. So I multiplied this by negative and that by negative. Or you could have done something as simple as oh, that's supposed to be a 1. So those would all be 0. All be a different way of writing it. I want you to think through on the talk and complete each statement with always, sometimes, or never.